Hello friends, welcome back to my YouTube channel. In this video, we will be initiating the discussion of non-parametric methods in data analysis. Non-parametric methods in data analysis. Before diving into this course, first we will just try to understand what the title of this course says, right? So as you closely look at the title of this course, we can identify a lot of terminologies. The first one is non-parametric, right? So we will see what non-parametric later, and now we will just explore data analysis, right? So now if you take the term data analysis, it refers to something like data is analyzed in order to get some information or idea to predict or to get some summarized information about the data, right? So first we will try to understand what data is, right? So data refers to raw facts, figures or information collected for analysis and decision making. It can come in various forms and is typically categorized into two main types, right? So now we have to understand, or we have to know how to define the term data, right? So data is a raw fact, or it can be a figure, or it can be an observation, and we usually collect the data from various resources, right? So we can collect the data from surveys, we can collect the data from databases, even we have online repositories from which we can download the data, right? So data refers to, I'm just writing the definition for data so that you can write down if they ask or if they instruct you to define the term data, right? So data refers to raw fact, or figures or information or observation, okay, collected from various resources, right? Collected from various resources. Now after writing this phrase, you have to think, or you have to ask yourself from which we can collect the data from, right? So we can collect the data from surveys, using surveys, databases and online repositories, etc., etc., right? And what are the advantage, or what is the purpose of analyze, or for this collecting data, right? So now we have to subject the data collected to analysis in order to make decisions, right? So for analysis and decision making, right? So the next topic, or the next point is, now we can classify this data into two major groups, right? So data classification. So we have two types of data. The first type is qualitative data, and the second category is quantitative data. Now we will try to understand the key differences between qualitative data and quantitative data. As the name suggests, qualitative data is just characters or attributes, right? So they cannot be measured numerically. On the other hand, qualitative data can be represented numerically, right? So we can measure as numerical values, right? So these qualitative data are used for categorical data, right? So categorical data, and here we can use qualitative data, or we can say in other words numerical data. numerical data. Okay, now we will just try to understand some examples for categorical data, right? For example, as we all know, gender, right? So gender can have majorly two categories. Anyhow, nowadays we have some other categories also, but I don't like to talk about them now. So gender can be either male or female. Okay, then the next example is, we can say opinion, right? So opinion about a service, opinion, right? So satisfied, so there can be three options, right? So satisfied, neutral or moderate, or not satisfied, or we can say dissatisfied also, dissatisfied, right? The next example is color, right? So we can ask some people about their favorite colors and we can get several responses. So some people may say blue, some people may say green, some people may say red, in which I am writing. Okay, right. So now these are some examples for categorical data or qualitative data. And on the other hand, we can have quantitative data also. These quantitative data are measurable. These are measurable and can be represented numerically as well. Numerically, right? So now we can, before looking at some examples for quantitative data, we will classify quantitative data further into two subgroups. The first one is discrete and the other one is continuous. Discrete and continuous, right? So under discrete data, we can have only countable values. Countable values. And on the other hand, under continuous data, we can have any number within a range, right? So this can take any number within a range. So any number in the sense it can take both integer and decimal values, right? So let me use a different color and tell that it can take both integer and decimal values. But here for discrete data we can have only integer. We cannot have decimal values. Okay. For example, number of students, right? So we can have 5, 10, even 1000 students, but we can never have 1.5 student, right? So this is practically impossible. And in continuous data, we can have examples as weight, height, etc., right? So now for example, I can have 50.2 kilogram as well. Another person may have 70 kilogram. So as you can see, we have both decimal and integer values. So using these types of data, we can draw conclusion, we can make prediction what will happen in future, and we can come up with informed decisions as well, right? And these types of data are used in a lot of fields like science, business and technology as well, right? So what are the purpose of collecting and analyzing data? Now we can just take purposes. Now we can draw conclusion, right? So drawing conclusions is one of the purpose or advantage of data analysis, right? So drawing conclusion mean, now simply we can tell, right? So if you take the, or if you collect the English marks of 20 students, now we can take a decision whether the English proficiency of the particular class is okay or should we improve it, right? So from likewise we can draw conclusions about the sample and population. And the next purpose is to predict, it is to make prediction, right? So prediction, right? So now in time series analysis also, this is what we do. Now we will predict what will happen in future, right? So this is one of the purpose of data analysis, and we can come up with informed decisions also, right? So these are just some purpose of data analysis. Now we have just looked at what data is, and now we will go for data analysis. Before that, we have to understand what analysis is. So typically analysis is systematically examining something by breaking it down into parts to understand it better, uncover patterns, relationship or insights in order to draw conclusions, right? So in the context of data analysis, this data analysis involves a lot of procedures or steps. We can first tell, right? So this is data analysis. Now data analysis involves a lot of steps. The first one is, first we have to collect the data. So the first and foremost step is to collecting the data, right? So let's say we have collected the English mark of 20 students. Then we have to organize it, organize the data. Now for example, if you want to find the median, then you have to arrange the data in ascending or descending order. That is typically organizing the data. Then we have to clean the data, and this can be called data wrangling as well, right? So if you are studying machine learning or data science, you may come across with data wrangling, right? So the term data wrangling can be often heard by your ears, data wrangling. Now the fourth one is processing, right? So now we have to process the data, processing the data. This is something like cooking the data, right? So this is the procedure in which we are applying statistical models and statistical knowledge in order to get some useful information about the data, processing the data. Finally, we have to interpret the data, right? So this is the final procedure, that is interpreting the data. Okay, now our results should be interpreted or described, right? So what has happened and what will happen, based like that we have to interpret the data. Now we will go for what data analysis is, right? Okay, right. So this data analysis is a key part of statistics and data science, right? So it involves the following steps as I explained you earlier. Now I think we don't want to study in detail about those steps. Now we will just look at the purpose of data analysis. Now sometimes they might ask the purpose of data analysis, right? So the next topic is purpose of data analysis. Now we have several purposes for data analysis. Anyhow, we will just list out some of them. The first one is decision making, right? So now for example, let's say I am a class teacher of a class, then I have to make a decision whether I have to conduct more English tests based on the performance in the previous examination, right? So this is one of the advantage or purpose of data analysis, decision making. I have to decide. Then the second one is problem solving. So problem solving helps identify patterns and trends that can lead to solution for complex issues, right? So if we have a sea of numbers, let's say we have a huge data and we have to solve problems, right? So we might be asked whether to continue this sales production, and many questions may arise and we have to solve all the problems. That is one of the advantage. And the third one is predictive analysis, right? So predictive analysis. right? So predictive analysis means we have to predict what will happen in future, right? So whether the sales will increase or there will be the downfall in the production rate. So whatever it may be, we have to predict what will happen in future based on the existing or historical data. Then the fourth one is, you can say, optimization. About this optimization we will separately make a video because this is not included in our topic. This optimization topic is studied under several fields. For example, even we can study under statistics also, data science, finance, mathematics, engineering, computer science. So in several fields this optimization technique is studied, right? So we don't want to go further into it. Now we will try to understand the types of data analysis, right? So our main objective is to study the two main methods that we have for data analysis. Now we are going to just have a look at types of data analysis, right? So type of data analysis. So in the types of data analysis, first we have descriptive analysis. Descriptive analysis. So under descriptive analysis, we can summarize the historical data to understand what has happened in the past, right? So this is our objective for our descriptive analysis. Let's say we have the English marks of 20 students, right? So we can find X bar, right? So we can just find out the average of the English marks of 20 students, right? So based on that, we can only tell what happened in the past, right? Okay, then we have the second type as diagnostic analysis. So under diagnostic analysis, we explore why something happened by identifying relationship and correlation, right? So we can just tell, we explore, this word is very important, why something happened by identifying relationships and correlations. So correlation, regression, so these chapters can come under diagnostic analysis. Okay, then the third type is predictive analysis, right? So predictive analysis. So using the existing or historical data and models, we can predict or forecast the future events, right? So now we can just predict the customer behavior. Now whether a particular product can be purchased by the customers or not, right? So these types of analysis can be done under predictive analysis. And the fourth category is prescriptive analysis. Right. So under prescriptive analysis, what we do is we suggest the best course of action based on the analysis of the data. It is something like the doctor analyzes or examines you and recommends some medication or some medicines for your disease or for your ailment, right? So this can be just used as an analogy. Anyhow, what we can do is, for example, optimizing inventory levels. So just let me write down the description of this prescriptive analysis. So it suggests the best course of action, the best course of action based on the analysis of data, based on the analysis of data. For example, optimizing inventory levels, right? So example, optimizing inventory levels. First we have to understand what inventory is, right? So inventory means nothing but stock, right? So all the goods that are available in a business or shop can be called as inventory, right? So the synonym, sometimes this word might be new to you. So inventory is nothing but stock, right? So stock management is very important in business, in handling the business, right? So optimizing the stock levels in order to improve the business can be done using this data analysis as well, right? So now these are the advanced application of data analysis. Now with that idea, we will just move to the two methods of data analysis that we have for statistics, right? So now this is the turning point of our lecture series. Now we will come to our topic, that is the two methods of data analysis. Two methods of data analysis. So what are the methods that we have for data analysis? So you have to ask this question to yourself, and you will get the answer as parametric method, and then non-parametric method. Right. So now we haven't studied any course called parametric methods in data analysis. Anyhow, for this semester we have non-parametric methods. So whatever the methods that we have studied in our previous semesters are called parametric methods, right? So the key difference about a parametric method and non-parametric method is, now in parametric methods we assume that the distribution or the data is normally distributed, right? So this is the key assumption that we made during our previous semesters, right? So here the key idea is, we assume that the data set is normally distributed, right? So the normally distributed data set will appear something like this, where we have mean is equal to mode is equal to median, right? So now parametric methods have a lot of assumptions, right? So under parametric methods we have a lot of assumptions, but in non-parametric methods we have fewer assumptions, right? So here we have a lot of assumptions. One of the assumption is the data set is normally distributed. Now we will just take a look of what the rest of the assumptions are, okay? Right. The second assumptions that we made is homoscedasticity, or we can call homogeneity of variance, right? Homoscedasticity or homogeneity of variance. Okay, right. So under homoscedasticity or homogeneity of variance, what we assume is, we assume that equal variances are available across groups, right? So we will study about this homoscedasticity. I will upload separate videos explaining each methods we studied under parametric methods in future, but our focus is to focus on, or majorly focus on, non-parametric methods for this video, right? Okay. Now the third one is, or we can say third assumption was linearity, right? So we assume that linear relationship exists between variables, right? So linear relationship exists. For example, let's say if one variable, if x increases, y also can increase or decrease, but we assume that the line is straight line, okay? But here we will study monotonic relationship. Monotonic relationship means if one variable increases, the other variable increase, but it doesn't always increase with linear line, I mean the straight line. It can be even the curved line. Okay, right. So when we study these methods, we can easily understand this. Anyhow, we have to know the assumptions that we made in parametric methods. Okay, right. And the next assumption that we made is independence, right? So we assume that the observations in a sample are independent, right? So independence. Okay, so we assume that the observations are independent, right? So now, for example, if we have taken the marks of 20 students, let's say 20 is one of the students' mark and 50 is another student's marks. So here this student and this student has no connection in obtaining marks, so they are independent, right? So one person does not rely on the other, but sometimes if they plagiarize, then okay, but we assume that they haven't plagiarized, or they have not dependent on the other one, right? Okay, observations are independent. Okay, then the next assumption that we made is sufficient sample size, right? So usually we take a sample size more than 30, right? So that is considered as sufficient sample size, right? So we consider n greater than or equal to 30 as large sample, right? Because if we have a small sample, we cannot perform the parametric test effectively, right? Because the variance will be high and they have some potential issues also. Now the seventh one is no multicollinearity, right? So under multiple regression analysis, we studied about multicollinearity. Now if we have more than one independent variables, they are not highly correlated with each other, right? So we will study about this multicollinearity under the topic of regression analysis, especially under multiple regression analysis where we have more than one independent variable, right? So the next assumption was no multicollinearity. Okay, so these are enough for now. Now we will move to our topic, that is non-parametric methods. Okay, so we already discussed that when the data set is normally distributed, when it follows this type of distribution, right? So when it follows this type of distribution, we can go for parametric methods. But when the data set does not follow this type of distribution, right? So let's say we do not have normal or approximately normal distribution, so we have something like skewness, right? So this might be positively skewed or negatively skewed, right? So for skewness we might have some other reasons also. Now if the data set is not normally distributed, right, so we will go for non-parametric method. So now we have to understand that non-parametric methods are used when the data set is not, this word is very important, not normally distributed. Okay. Right. Now if the data set is not normally distributed, then we can call it as skewed, right? So for skewed data we can apply non-parametric methods for skewed data. Right. So what is skewed data? now the skewness may occur for due to several reasons, right? So now we can say this is one of the type of skewness, right? So the first one is positively skewed and the other one is negatively skewed, right? So positively skewed mean it will be something like this, and negatively skewed mean it will be something like this, right? The slope is in the negative portion. Now the skewness may occur due to several other reasons also. Now if you have kurtosis, right? So skewness, kurtosis. Now skewness may occur due to kurtosis also, right? So we have three types of kurtosis. To remember them, you can remember this order, right? So in the alphabet we have K, L, M, N, O, P, right? So now we have three types of kurtosis. The first one is leptokurtic, and the other one is mesokurtic, and the other one is platykurtic, right? So leptokurtic begins with L. So here the first one is L, and the other one is M, and the other one is P, right? So L for leptokurtic, M for mesokurtic, and P for platykurtic. This kurtosis measures the thickness of the tail, right? So now if you assume a normal distribution, now these tapering ends are called tail, right? So here we do not have any tail, or this is called standard normal distribution. But here you can see these are tail and this is also tail, right? So these are the tapering ends, right? So now mesokurtic means this is normal tails, right? So this is just normal tail, right? So these are normal tails, but here now let's say this mesokurtic is the kurtosis value of 3, right? So if Ku is equal to 3, we can call this as mesokurtic, and if Ku is greater than 3, we can call it as leptokurtic, and if Ku is less than 3, we can call it as platykurtic, right? So you should know the kurtosis values for leptokurtic, mesokurtic, and platykurtic, right? So how can you remember this order? In the alphabet order we have L, M, N, O, P, right? So L for leptokurtic, M for mesokurtic, and P for platykurtic. Now what are the Ku values of leptokurtic, mesokurtic, and platykurtic? They are 3, right? So taking 3 as the reference value, we can tell if kurtosis is equal to 3, right? So if the kurtosis value of the data set is equal to 3, we can call that as mesokurtic, right? So it follows a ideal normal distribution, right? So this is an ideal normal distribution. But if it is leptokurtic, then we can call it as high-tailed distribution, right? So leptokurtic is called high-tailed distribution because the thickness, if that is a high-tailed distribution, then we can tell that the thickness of the tail is high. Or in other words, we can tell that the peak of the distribution is sharp, right? So now this is how we can draw the leptokurtic, mesokurtic, and platykurtic distribution, right? So let me use different colors so that you can easily understand. Now let's say this is the ideal normal distribution. Okay. Now this is the format of leptokurtic. You can see the tails are thickness. The thickness of the tail is high, but here this is moderate. But if it is leptokurtic, platykurtic, now this will be something like flat shape, right? So now you can see this is something like this, right? So now here the peak is sharp, here the peak is also moderate, but here the peak is, the sharpness of the peak is also very low, and the thickness of the tail is also very low, right? So thickness of the tail is high, or sharpness of the peak is high. Okay, so now we can tell two characteristics for leptokurtic distribution. Now the thickness of the tail, right? So we have two parts of this distribution. Now let's say this is something like a mountain, right? So if the tail, or if the bottom area is called tail, now this is called tail, and this is peak, right? Okay, peak. Now if the sharpness of the peak is high, or the thickness of the tail is high, we can call this as leptokurtic. And in mesokurtic we have both in moderate size, and in platykurtic we will have both in low size, in small size. Okay, right? So both the thickness of the tail and the sharpness of the peak will be low in platykurtic distribution, right? So the next factor that can make the distribution skewed is bimodal or multimodal distribution, right? So if in our data set, if we have more than one modes, we can have okay, now we can classify the data set as unimodal, bimodal, or multimodal. Now if it is unimodal, we can expect to have normal distribution, right? So because it will have only one peak. But if we have two modes in bimodal distribution, or in bimodal data set, we will have two modes, right? So now basically the peaks represent the mode, right? So the peaks represent the mode. So if we have two modes, then the data set will appear something like this with two peaks. So this is not our typical normal distribution shape. So we cannot apply non-parametric methods for bimodal distribution. And multimodal means if we have more than two, right? So let's say we have three modes, so it will be something like this. So it is not a normal distribution, so we cannot apply parametric methods for this type of distributions or data sets. Okay, now in this case we better avoid using parametric methods for our data analysis, as it might lead to some improper or misleading answers or results, right? Okay, now but we can do some other alternatives also. For example, we can perform transformation, mathematical transformation, or we can just divide this or we can just treat, or we can divide this bimodal distribution into two data sets and perform the data analysis. But that is not always possible, so we better go for non-parametric methods. Okay, so what we have discussed is what factors can make a distribution or data set skewed, right? So first we can discuss, by default the distribution may be positively or negatively skewed, and then we talked about kurtosis, and then we talked about bimodal case and multimodal cases. And now outliers also can make the distribution skewed, right? Because it damages the shape of the distribution, right? So if we have odd or extreme values, they can distort the shape of the distribution. Now we will just see what methods that we have studied under parametric methods, right? So we have studied a lot of methods under parametric methods, and now we are going to study a lot of methods under non-parametric methods also, right? So for a clear understanding, what I am going to do is I am going to classify the data set that we can be given into several categories. Okay, right? So now classification of our data. So classification of data set. Right. So I am going to classify our data sets that we can be given in our exams or in our research or whatever the survey it may be. There might be around 5 categories, right? So first we can tell one sample, right? So for example, if we have been given a series of marks, so that is one sample, right? So now I'm going to tabulate the data set and the methods that we can use under parametric and non-parametric, right? Yeah. Okay. So the type of data set, and if we have decided to perform parametric methods, and then we will see what are the non-parametric methods that we can use alternatively. Okay, non-parametric methods. Right. So first let me summarize these, then we can study one by one. Right. So the first type of data that we can have is one sample. One sample. So here we have only one group, right? So for example, if we take the 20 students English marks, that will be one sample. So here under parametric method, we can simply use simple t-test, right? So simple t-test can be used. But under non-parametric methods, we have to perform Wilcoxon test. Right. Now we may have two sample test, but now if we have two samples, that might be independent or dependent, right? So we may have two independent sample and dependent samples, right? So two dependent sample, for example, before and after cases. So for two dependent sample, we may use paired sample t-test. And here we can use Wilcoxon test. Right. Now the third type of data that we can have is two independent sample. For example, if we have taken the English marks of boys and girls separately, they are not dependent each other, right? So two independent sample. Now for this type of case, under parametric test, we can use unpaired sample t-test. Unpaired sample t-test. But here we have to use Mann-Whitney U-test. Here Mann-Whitney. These terminologies or names might be quite different or quite new to you. Sometimes you may feel strange also. Anyhow, you will be familiar with these things with time. Mann-Whitney U-test. then more than one independent sample. We may have more than one independent sample, right? So we may have 3 groups and they are independent samples, more than 2 independent samples. Now you see, one sample we have 2 sample and 2 dependent and independent, and now we may have more than 2 samples also, and they also might be dependent to each other, or they might be independent as well, right? So the fourth category is more than 2 independent samples. Here independent sample, and fifth one is more than 2 dependent sample. Okay, right. So for this category, what we will use is, now we can, okay, for more than 2 independent sample, we may use 1 factorial ANOVA test, right? So 1 factorial ANOVA test. And for this we will use Kruskal-Wallis test. Here under non-parametric methods we will use Kruskal-Wallis test. Okay, now if we have more than 2 dependent sample, we will use repeated measures of ANOVA, right? So repeated measures of ANOVA, analysis of variance, but here we will use Friedman test. Okay, and in addition to that, we may have correlation between 2 variables. So for correlation, for checking the correlation between 2 variables, right? Correlation between 2 variables. Now here we have studied Pearson correlation, right? Pearson correlation, and here we will study Spearman correlation, right? So you can just remember, parametric method start with P, and Pearson correlation also starts with P. So P for P, right? So Pearson correlation is for parametric, and Spearman correlation for non-parametric test. Okay, right. So I think with this I can wind up this lecture, and in the next lecture, from the second lecture onwards, we will be dealing with the calculation part, right? So from the second lecture, I will start with this Pearson correlation and Spearman correlation, and after that we will study about these non-parametric methods that we have. First we will study Wilcoxon test and Mann-Whitney test and Kruskal-Wallis and Friedman, and in addition to that we will study one sample sin t test and others test also, right? Okay, so if you have found this video useful, and if you have learned anything new, please subscribe to this channel and share with your friends also, and we will begin the second lecture shortly, and I will upload video explaining Pearson and Spearman correlation together, and then we will move to the other types of parametric non-parametric methods, and after finishing non-parametric methods I will try to upload videos explaining parametric methods also. So bye.